What's up guys, this is Ronnie. Welcome back to our channel Total Technology Zone. This is tutorial 106 and today's topic will be very interesting. So this is the official introduction where I am starting the Langraph integration with LangChain. Okay, so I got multiple requests that when we are going to start Langraph, so I think this is the right time. We should start working on the Langraph, right? So before I start the video, I'd like to say a couple of things. First thing, sorry guys, for last 5 days I was not uploading any videos because my health was not good. I was actually having fever, and still I am having some bad throat and uh, some cold and cough related problems are there due to sudden weather change in my city. And if you hear uh, properly, then probably you'll understand my voice is actually not normal. So it's different because I still have the fever. Okay, but still I want to upload some videos, so here it is. Okay, next thing, before I start the video, guys, please try to subscribe to my channel. If you're new to our channel, try to go ahead and watch the video from the tutorial 1, because this is tutorial 106, so you can understand. Before this tutorial we have already uploaded or created 105 videos, right? So 105 videos are actually huge, right? So that is the thing I would like to highlight. And last but not least, try to share my videos, try to subscribe everyone guys, because until and unless you guys are not subscribing, my subscriber count will not increase. And the moment you guys start subscribing, my audience base will increase, and Google or YouTube, whatever, they will also promote or push my videos to the large number of audience. And also it will get some sort of reach from the YouTube algorithm. My ultimate goal is actually to reach the large number of audience, so that I can grow my channel gradually. So your help is required for my growth. Please help me to achieve my growth, and I'm promising that I will always come back with nice and quality content. And don't forget to hit the bell notification icon as well, and try to share my videos as much as possible. And the last thing, if you find these videos are helpful and helping you to do something on your work or study or anywhere, please let us know, so that this will also motivate us, and also this will help other people to find this video useful. And if you think something could be done in a better way, something is missing, or something you want me to actually include in the next tutorial, please let us know in the comment section as well. And also I have given my Telegram channel link. You can join in the Telegram channel and you can discuss with me directly. Okay, so enough of talking, we'll start working on the tutorial part. So in this tutorial I'll be going to set up a very simple Langraph with LangChain. So when I say Langraph with LangChain, it doesn't mean that you have to use Langraph with LangChain. You can independently use Langraph without LangChain, but our objective is actually to do some sort of LLM-driven application development. So we have to use LangChain for a couple of things. For example, some agent related operation, for data integration related things. So I thought of creating this tutorial as an integration or bridge between LangChain and Langraph. But Langraph basically developed by the same company who developed the LangChain. So basically it's a product from LangChain only. So they name it Langraph, but it's the same company, LangChain. Some logistical like things. Okay, so what exactly you gonna do? Simple use case with Langraph. So in this tutorial, I'm not going to build anything. Rather than I'll be just going to develop some sort of intuition for you guys that how Langraph actually works. Okay. So here is the picture. So basically node 1 means you can think it as a Python function. You can think this is an agent or whatever. So agent or function will be added to a node. So graphs means what? Graphs means nodes and edges, right? Like from you can imagine that it's a metro station in some city. Like metro stations connected via some sort of route between them. Like for example, if you are going to New York from some city from, let's say, New York and New Jersey, they are connected between a rail station, right? So you started from New York, so it is a node, and you are going to New Jersey, so New Jersey is a node. So this sort of things are actually easily implemented using graph, this sort of use case. So basically node, you can imagine in our case it will be either a Python function or maybe an agent. Like if you are doing some LangChain pre-built tools, then probably you don't have to write function, but if you are writing your custom code, then probably have to write a function. So node 1 started from your execution started from node 1, and here is a conditional age, means it will check the response from this one. If it is yes, then it will go to node 2, and if it is no, then it is going to node 3. So I'll be just going to develop this thing, and once you are able to understand this logic, you can actually build any complex operation. Okay, I'll be just going to do very simple thing. And next thing is, actually this is a tutorial source code link. You can get it from the GitHub, and also I'll try to upload the link as well. Okay, so enough of talking, let's minimize this thing, and I would like to complete the video very quickly. So first of all, if you see here, I have created couple of agents, right? Node 1, node 2, and node 3. So what I'll do, I'll be just going to first create uh, agent 1. So basically agent 1 is actually your agent who is actually going to receive the response. Okay, right? So agent 1 is actually going to receive your response, nothing else. Okay, so just hold on, let me write the agent 1. So it should be, it is just going to read the response and reply, nothing else. Okay, so maybe def check input. Okay, so there what we'll do, so it will be request equals to string, right? And now it is going to be check against this. So basically we have to check that whether the input is actually having yes written or no written. That's it, nothing else. Okay, okay, so if request equals to yes, then uh, then what will happen, then we would like to return with an yes actually. Okay, means if it is actually coming with yes, then probably we'll be going to redirect it to somewhere else. Okay, so then return I think and why I'm doing this thing, I'll tell you. Okay, and okay, so if it is going to get a response of this, this is get and this is like this. Okay, so now my agent 1 is developed. Now what we'll do, we'll be going to actually write the agent 2. So basically agent 2 will receive the this thing, and it is going to just return something. Okay, so what we'll do, write yes, right? So I'm just thinking what has to be written here. So just thinking, okay, so here it will be but here it will be state only, because in the state it is going to get the response. And I'm just thinking, just give me a moment. Okay, so like this. Okay, I think if I do with agent related, then probably it will be little bit difficult for you guys to understand. So let me start the code from the beginning. So just forget about that. Let me start writing the code from the beginning, like from the graph. Okay, from main.py. So that will be our entry point. Okay, so let's start writing the code from there, and maybe that will be a little bit easier for all of you guys to understand. So first thing you have to actually from Langraph, Langraph, okay, dot graph, okay, import graph, okay. So let's first this thing, and now what we'll do, we'll be actually going to import couple of more things, that is from Langgraph.graph, okay. I think state graph and end. I think we can put it here as well. State graph and end. Okay, that's it, done. Okay, so our graph related things are done. Now we'll be going to actually import couple of other things, like, just hold on. I'm just thinking what else we can do. Okay, so let's do from typing import I think it will be type dictionary, okay, then annotate, and then sequence, and then import operator. Okay, okay, so all done. So basically, within your graph, we want to actually manage the state, and states are actually what? States are basically messages passed from the user to one agent to the next agent. Like, first user will send some message, then the message will be passed between various agents. So that will be the state will be going to hold. How to actually do it? So we have to create, let's say, class, okay. Here agent, it will be agent state, okay. So we'll be going to write agent, okay, type diction, okay, 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 messages, then annotate, okay, sequence, then str. So this sequence is actually a string. Basically the messages will be actually uh, and then it will be okay, like this, okay. Now what will happen, we'll be going to set the workflow. Okay, so workflow is actually state graph, okay, and then agent state, okay. So I'll be going to manage this workflow using the state graph, and this is actually going to take agent step in every input, every step it is going to take the input from the messages, right? Now I'll be going to set up couple of things here. So I'll be going to create this, first part is done, check input. So what I'll do, I'll be going to add add workflow dot add node. Okay, add node. So I'll be just going to give a name like node1, and in the node1 the name of this thing is actually what? Agent1, right? So let me write correctly. We're just going to write node1, right? So it's check input. Okay, so what I'll do, I'll be just going to write check input, right? So this is not going to be an this thing, this is like this. So here it is actually going to give me error. So for that, what we have to do, we have to import from node1 import check input. That's it, my node1 is ready. So once node1 is ready, I have to actually write a function where to go. Okay, I have to write a function where to go. So where, no, first before that, we need to actually set up couple of other things like we need to actually set the workflow entry point. So workflow dot set entry point, and in the workflow label set entry point, I'll be just going to write node 1, right? My workflow is ready here, right? Then we have to just compile that workflow. Okay, app equals to workflow dot compile, right? It is done. Now we have to actually create a function here, right? Def get answer, and basically this is going to actually receive an input like question. Okay, so this question will be actually going to be sent by the user, right? So question could be anything. So what I will write, I'll be for the time being, I'll be just going to make it manual. So response, I'll create a variable called response. So response means what? Response means is actually this app dot invoke. Okay, and here within that app dot invoke, I have to actually pass this question. Means basically app dot invoke, and after that I have to pass this as a dictionary, because at this moment this dictionary is actually not created. So basically I have to write messages and there this question, right? So my response is created, an app doc means is actually this is going to form like this. We have to manually form this thing, because I have written that my messages will be a list of sequential string, and that will be actually managed in the state. So this is done. So when I execute this thing, what will happen? This is going to return print response. Okay, response. So basically when I say this thing at the beginning, it will go to this node only, node1. So node1 means is actually it is going here, and it is actually going to print this yes. If I write yes, it is going to print yes. If I write yes, it is going to write no. So let's print this thing and let's see what is happening. Okay, so let's execute this thing. Before that, we have to actually call this function get answer, and we'll be going to write with yes. So I'll show you if there is any error or something is missing. So let's execute this main.py. I have executed. See, message yes. Why this message yes is coming? Because this response, I have written messages of yes, and that response is actually coming from here, right? Okay, so this is the response actually coming. This is a response of messages is actually coming. So different things are there. Now what I'll do, I'll be just going to write here no. Okay, so let's write no here. I got no. So now I'll be just going to write something different, and let's see what is actually happening. Okay, so TTT. So this print response is actually not getting executed. Why it is not getting executed? I just set this workflow entry point as node1, and just hold on. Then after that, I'm actually returning here if request equals to this, it will be yes, and it is no. So we have to make sure like after this node where exactly it is going. Okay, now we have to actually set some conditional node here. Conditional nodes are actually not added here. Okay, so that conditional node we have to add, okay, after this thing. Okay, so it should be workflow dot add conditional edges. Okay, so conditional edge is actually going to start from node 1, right, like this. So first thing is actually it will start from node 1, remember, and here we have to actually write a function. Okay, so function will be going to write here at the top little bit. Okay, where to go, and just hold on. Okay, okay, workflow dot where to go. Okay, here def, so you have to actually write a function so that where it should go. Okay, so where to go, like this, like this. So basically where to go basically takes an input as a state. Okay, and here we have to decide. So if let's say ctx equals to state of messages. Okay, so always the message will be the first message from here, right? If ctx of 1, then it will go to, let's say it will go to return node 2. Okay, okay, if ctx of 1 equals to no, node 3. Okay, okay, so I say like why I say this thing, because if you see here you will understand now what is exactly happening. And here I just write where to go, and in the conditional logic I will write where to go, right? And in the where to go we'll be going to write some additional logic, and that is actually going to set up your, what do you say, like set up your this thing. Okay, so let's see. Okay, so basically if it is node 2, node 2 means actually what we'll be going to write. Okay, okay, so basically we'll be going to write, if it is node 2, then it will be node 2 only. Okay, and here we'll be just going to write everything will be a dictionary. Okay, so node 3 means node 3, and suppose user enters something which is invalid. Okay, so here you can just write else. Else means anything other than if and else, so user have to return okay na, right, return na. Okay, so what I'll write if else, okay, else what will happen, else it will return end. No, this ended, it will be end actually. Okay, so now we have to actually check what is end. Okay, so end will be going to write like this. end will write like this, and if it is end, then what will happen, everything will stop here. Okay, so like, and this is actually end. Okay, so that's it. Like what it is saying, that user enters yes, and if user enters yes, it will check if the message is yes, it will go to node 2, and if it is no, node 3, and if it is other than yes and no, it will end here, right? And node 2 means is actually this node 2. Okay, this agent 2, so I'll be going to name it node 2, right? So write yes. Okay, so this is state. So now state means what? State means you are sending something, and always you have to get the last message. Okay, so maybe user message is actually input. What user input, we have to find that. So that will be actually state of messages, and we have to actually get the last message. Okay, right? I think last message in the input is probably like this. Okay, because I think last message only it will be, not the first message. Let me think. Uh, just let me think. Yeah, state those messages -1. So like that way it will be coming. Yeah, I think. Yeah, that is the thing. Mm, yep, and what we'll do, we'll be just going to write messages and write user entered Okay, so what I'll do, I just want to actually print the state here so you'll understand. Okay, so what is happening. Okay, so let's see, if I do something wrong it will come here. So what I'll do, I'll just first go ahead and check with yes. Okay, so let me actually execute the main part with yes, and let's see where to go. Branch unknown target node 2, because I don't write anything for node 2. So it is saying the target is unknown for node 2. Where is the line? Hello at node, where to go? Unknown target node 2. So it is saying that unknown target is node 2. Basically I did not add anything here. Okay. Okay, node 2, and node 2 is actually write yes. So let's write yes here. Okay, so what we'll do, from node 2 import write yes. Okay, let's execute. Hopefully this will work now. Yeah, so node 3 is missing. So let's say in the node 3, what I'll do, I'll just copy this thing from here. Okay, write no. Okay, so I think it will be, let's hard code this thing. Okay, and here user entered no, like this. Okay, okay, everything is fine here. Let's execute and let's see. Okay, so it is saying unknown target node 3 because I did not add node 3. So what will do, so see, if you don't add anything, it will always give you error. Node 1, node 2. So I have to write, make it node 3. From node 3 import write no, and here I have to add them as this node 1, node 2, node 3, and here I have to write. Well done, let's execute. Okay, so TTTNA. Why it is TTTNA? Now can you tell me why it is TTTNA? Because I wrote TTT here. So first message was TTT, right? And when actually it was actually went here, just hold on, get response. So get response is actually going to print the response. So TTT means what? You have to understand. Uh, just hold on. I said TTT. So TTT basically went here. This get response here app dot message response is here, and it is actually printing the response. Well, here, just hold on. Let me actually remove this thing and let's see what it is coming. It is not printing basically anything, so it is printing from here. Okay, so now you have to understand. First it will go here. Okay, and now what is happening, it is actually checking this app dot messages. App dot messages is actually what? App dot messages is actually here. So you have to check here where to go, right? So in the where to go, let me write something here first. State message, you will understand what is happening. Okay, state means the current state. Okay, so if you see here, when I execute this thing, first it will go to node 1, and from node 1 it will go to this function to check. In the check, I will be going to print the message. So let's see what is actually coming. So it is actually TTTNA. So I don't know from where actually this TTT is actually coming, you can say, but if you see here, it is actually available here, TTT, right? So this TTT is actually coming from here, right? And now let me check why it is actually showing some extra NNA. That is something I have to check. Just hold on. And if this is here, it is getting here, it is, yeah. So I'm printing this thing here. So it was supposed to be print only TTT, and it is actually printing some extra not available. Okay, so that is something need to check here again here. Okay, so written messages is actually NA. Okay, TTT, and then NA messages equals to NA. So state, print state where, so it is actually going to be end here. Condition and not invoke. It is messages, it will go here in this message. It is okay, so I'll tell you what is happening here. Okay, so yeah, so see, you have to understand very logically. Okay, so our graph started on node is actually here, right? So our node is actually here, and node is actually having the value of TTT. So node is actually here, so it is executed, means it will execute, right? So in the node 1 it will go, so message is actually here, TTT, and then NA is actually here. Okay, so because of TT it is coming here. Now what is happening, we are checking against here again. Now where to go, have to execute. Node 1 is executed here. If you see here, already node 1 is executed, this node part is executed. Now we have to go and check this where to go part. In the where to go part, it is actually having here. So if it is yes, then this is actually not, this is this, and else is equal to node 2. So if it is end, there is nothing. So basically I'm telling you the execution is what, this TTT, first it will check the entry point. Entry point is actually node 1, so it will come here and say, so it is checking the input. So input is actually not yes, not no, the input is actually NA, right? So request is actually coming from here. Now the question is actually how it is actually checking this request. Okay, so what I'll do, I'll be going to print the request here. Okay, I want to validate this thing. So what I'll do again, one more time. So it is TTT, message is actually TTT. So we have to actually request. So this request is actually this thing. Okay, so we have to actually get this value from here, request dot messages. Okay, so you can actually like something state. Okay, everything will be state here, remember. Okay, always it will be a dictionary. So basically I have to write request equals to, always it will be the first message because it is the beginning. Okay, and it will be the first message, remember. Okay, and then we'll be just going to print request. Okay, right, let's execute one more time from here. So I'm just fixing everything. So it is TTT, right? So TTT means actually what? TTT means is actually it will come here in the NA, right? So NA comes and now it is actually validated against this thing. Okay, so now we go here with state means is actually this thing. Now what is actually state of messages? State of messages of one, the second message, it will be checked always. Okay, remember. So either you can use 1 here or either you can use CTX1 here, it doesn't matter. So CTS1, so it is CTS1 is yes means yes, it's like N means no means no, and yes means is actually node 2, no means node 3, end means end, and it will stop here. And after that it is again going to print the response. Response means is actually the same thing. Response means nothing will be printed because it is haven't done anything here. So now what will happen, we'll be going to actually state with yes. Okay, I'll tell you what is actually going to happen here. So if you write yes, what will happen? So basically this yes is actually first execute here and it will be going to get yes. So it will be TTT yes. So it means here it will print TTT yes, and then it will go to node 2, right? Now node 2 means is actually what? Node 2 means is actually it is going to print this one again. So basically it will be messages, then user entered yes, so that will be coming. Okay, so let's execute with yes. Okay, so let's execute. Yes, so first it will print yes yes. Why yes yes? Because in the node 2 node 2 is what is happening. If you write yes, okay, if you write yes at the beginning, uh, it will be actually going to be like the state. So first state message is actually yes. Okay, so print state, just hold on, messages of yes and yes. Okay, so you have to understand why this is happening like this. Okay, so let's understand one by one. We'll be going to answers. Okay, so first I write yes. So yes is actually means what? It is always going to execute the node 1. So let's go to node 1. So node 1 is actually writing that if it is yes, message is actually yes. So one yes is there, the second yes, so yes yes, right? So now it will come to here. So first it will print yes yes, then it will go to node 2, right? In the node 2 what will happen? It will go and check, right? In the node 2 it is go and check. So node 2 is actually here. Node 2 means is actually message, and then it will be added user entered yes, right? That will be added. So it means yes yes, user entered yes, right? And exactly that thing is actually printed here. So yes yes, user entered yes. Now the question is actually from where actually the second this thing is coming. We have only one print statement here, right? That is checked here, and here I'm just thinking yes, so that is the last print. So from where actually this this print is actually coming. Yeah, so we have also a state here, that is why. Okay, so here also from the node 1 we are writing getting yes yes, and then we are checking this thing against this thing, right? Node 2, in the node 2 also we have a state yes yes, that is printed here, and after that in the node 2 execution, if it is yes, user entered yes, we have to write in that way, right? So user entered yes, and that will be the final thing, and I got this as a response. Right now what will happen, I don't want them to be like this, and also in the main also I don't want to be like this. No, now if I just write no, it will be no no and user entered no, right? Okay, sorry. Okay, so it will be here. So user entered no. From the node 1 also it is giving a response of no, and from the this thing from node 3 it is actually user entered enter the no, right? So basically based on the user input you are getting an output. So basically the final response, if you just want to know the final response, so you have to do what? You have to actually write messages and -1, the last. Okay, so let's execute. We'll be going to get user entered no, right? That's it. Okay, so that is how we'll be going to get going with your Langraph and LangChain. So basically, let me reiterate one more time. So if you entered no, it will go to node 1 entry point. So node 1, it is actually going to check, okay, if it is yes, then it is going to return this. If it is no, it is going to return this. It is going to do this thing. So it is going to return now this no, right? Now again, just because we have a conditional logic here, at the next line where to go, it will go to this function. It will check now what is the message. In the message means is actually I'm checking the second message, not the user entered message. I'm just checking the message which is coming from node 1. That is the second thing, and check if it is yes, then execute the node 2. If it is no, node 3. So I said it is no, so node 3 will be executed now. So let's go node 3. So node 3, what is happening? We'll be going to get the message from it. Basically this line is actually not required because we are not doing anything here, but still if you want to know the last matches, you can actually do it from this one, right? And then we are setting user entered no. So in the message element, we have three things like yes, no from the user input, no from the node 1, and no from the node 3, and finally it is printing that. Okay, so this is a little bit complex, and I just want to actually give you guys very simplistic way of doing it. So that is why we are actually doing this small tutorial, and in the next tutorial I'll be going to start developing small use case, and literally we'll be going to reach to a level where we can easily get started with the advanced use case with Langraph. So probably I'll be going to require 3 or 4 small tutorial with Langraph and LangChain, and maybe after that, maybe next week or first week of, or maybe mid of August, we'll be going to do some sort of very advanced use case with LangChain and Langraph. Okay, with that note, I'll be just going to conclude the video over here. And before I conclude, I'd like to request you one more time, guys, please try to subscribe to my channel, hit the like button. Okay, share my videos with your family and friend, and don't forget to hit the bell notification icon so that you should not miss any of our future updates from the future videos. Okay, so enough of talking, guys. Let's see in the next video. Till then, take care, goodbye, have a nice day, and happy learning.